All right. Let me get some water real quick. Equity tax. Equity tax. Here we go. Advent of Code, day 13. This is um technically it's when I do part one, that's the halfway mark, but day 25, part two is basically always do the other 49 stars. All right, lobby of a tropical island. Okay, test input. Let's figure out what all this means. This looks like a searching problem, just at a quick glance. No, no, I want it over there, IntelliJ. Okay, test input. Is that accurate? Um, yeah, okay. So, let's try to figure out what this means. There's a strategy for going fast where you read from the bottom top, apparently, but okay. We're playing with claw machines. Claw machine here are a little unusual. Instead of a joystick or directional buttons, these machines have two buttons labeled A and B. Whereas you can't just put a token to play, it costs 3 tokens to push A, 1 to push B. Interesting. A little experimentation, you figure out the machine's buttons are configured to move a claw a particular amount to the right, a particular amount forward along the y-axis each time the button is pressed. Okay? Interesting. Each machine contains one prize. To win the prize, the claw must be positioned exactly above the prize on the X and Y axes. You wonder what is the smallest number of tokens you would have to spend to win as many prizes as possible. Interesting. Okay. Is this? I feel like this is a Dijkstra's. I feel like this is a Dijkstra problem. So pushing machines. Okay, looking at the first pushing A94. Okay, so let's do the first. We're gonna do a little bit of advent of parsing right now. So let's go ahead and do that. So it's broken into groups of 3 lines. Going to be lines dot windowed, and it's going to be size 3 step, and it's going to look weird, but step 4. And from there, it's just going to be we're going to do let's see. Val machine. Or no, class machine. It's going to be class claw machine. And it's going to be AX val AX and let me just make sure all of these are ints. They are. Oh, I'm putting this in the wrong place. It's going to be val AX int, and this is a data class. Val AY int, going to be AX, AY, val BX, BY, and then val target X, target Y. And then this is just going to be, okay, so for these lines, what is this? This returns, we're going to map it to, call them machine. That's machine text 0. Going to be then it's going to be claw machine text 0 dot substring after going to be x plus dot substring before comma. Oh, yeah. I want this, but it's going to be now substring and then it's going to be substring after y plus and we're going to do the same b, but it's going to be line 1, and then we're going to do prize it's x equals y equals. Okay. Oh, right. Dot to int. Okay. I'm trying to figure out if this is going to be like a breadth first search, since we're trying to find the shortest path. But let's just real quick do print line. Right, because I need to do this. So let's print the machines. Oops. Or input string x plus a. What? Why am I getting substring after substring before? How am I not getting, let's do, hang on. What? It seems like that should be working. Oh, duh. I. This is why you don't copy and paste code, you bald fuck. See, when you copy and paste code, you make an ass out of you and me. Right. Okay. I did do it right. Sort of. Means not for each, just so I can read it a bit better, print line. I'm just making sure that I'm getting all my numbers right. Yep. All right, yepers. So from there, okay, so it said const val a token cost equals 3, const val b token cost equals 1. So this is going to be some kind of optimization. What's the smallest number of tokens you could spend? Okay. So I could try a breadth first search, and we'll just see if that works. Which it turns out is basically the same thing as a breadth first or a depth first search. You just switch out the stack for a queue. So that from the clause initial, it would need to move X, blah, blah. Okay, the cheapest way. You know, in hindsight, breadth first may not work because that's going to end up with a really big queue, but we'll find out. The cheapest way to win the prize is by pushing the A button 80 times and B 40 times. Line up, blah, blah, blah. Okay. All right. So the most prize you could possibly win is 2. The minimum number of tokens you'd have to spend to win both prizes. You estimate that each button need. Oh, okay. Well, that makes it. I mean, at that point, I can brute force it, but I know I'm gonna pay for brute forcing it if I try. Um. Actually, there's an easier way. Okay, so first, I have to be exactly over the prize. All right. So we're gonna look at this. I'm actually gonna move this down here just so it's a bit more in my eye line. I should lower my monitor a bit. All right. So, I think what I want to do is let's start by looking at um okay, so let's try B so for let's try this. Val max B presses equals going to be machine dot for each and the maximum possible B presses are going to be and by the way, just a heads up, I'm limiting myself to about 45 minutes on this total. So I know I'm going kind of slow right now, but I'm just trying to think like, okay, so it would be machine dot. See, the trick is that I have to look at two coordinates. Let's do it this way. Let's do the maximum number of times I could press B would be the minimum, taking advantage of the fact they say 100. The minimum of 100 and then it's going to be, this is a bit awkward, but it's machine dot I min 100 machine dot target x divided by machine dot bx. I'm going to change this to a max just because it makes more sense to start with a. Comma. So, right, I'm getting the minimum of these three numbers because that's. Can I not do the min of multiple? Whatever. I'll just do list of. I'm sorry. Part of this is me just sort of exploring Kotlin syntax. Okay, we're gonna do the min of that. Val B max. I'm gonna guess that like this is somehow gonna become like an order of magnitude larger, or like several orders of magnitude larger. So this is now target x bx, target y by. Okay. And for now, what I'm going to do is I'm going to do print line machine dot dot target y $, Amax, Bmax. And what I'm sort of getting to here is I kind of just want some idea of oops, I know what I did wrong. Okay, yeah, I'm recognizing that I'm actually pretty tired, so I'm gonna try to do part one. I'm probably not gonna try to do part two unless it's very trivial, which I fully expect it not to be. Right. Okay. So to be clear, they said right. So here's what I'm actually gonna do. I'm getting rid of Bmax because I'm going to do Amax. So for A presses in 0A, not A token cost, 0A max. What I'm going to do is I'm going to just get, okay, val diff x equals, and it's going to be machine.targetx minus A presses times A, or times machine.ax. And then if B, because it has to be exact, this is important. I actually, now I think about part two, is going to be like, oh, you have to get a range, and that's going to make it, I don't know, easier or harder. We'll find out. But if B if diff x mod bx equals 0, actually, I'm going to say then continue. We know we can't reach the point exactly. God, at that point, I feel like the only thing I could do is if it's a range around. I'm trying to, let's stop thinking about part two. Otherwise, we're gonna just get the value. So val b presses equal machine, or going to be equal to diff x divided by machine dot bx. And let's just do print line let me just see if I catch the combinations here first before I do anything else. And okay, so all of these combinations work. And I can actually go further and say, so they said that the most I'd have to press is 100, right? Which I guarantee this is going to bite me in the ass to use this information. That's just a rule of thumb. But you estimate that each button would need to be pressed no more than F. So I can do something like if diff x is greater than 100 times machine.bx, or it's not evenly divisible, because this should be a faster calculation, I think. Okay, there we go. So now I have now, let me cut this out real quick because I noticed something and I just want to make sure that I'm not misinterpreting it. Wait, my code's saying that the third machine is solvable. The second and fourth claw machines, there's no combination of A and B processes that will ever win the prize. What? Equals. Let me double check my math here. Uh, machine AY plus oh, that's right, because I forgot that Y is a whole thing. That Y checks our math. Um, and so this is the calculation that gives me Y. If machine dot target Y does not equal that, then we continue. And let me make sure these are the right combinations. Cheapest way to win this. Okay. All right. And then 3886. Yep. Okay. All right. We're getting the right result with our test data. So now, specifically what I need to do is I need to do val best token cost equals, and it's going to be int dot max value, val best presses equals pair -1 to -1. All right, I can just do -1 to -1. All right, that's a pair. Yeah. And from there, actually, I'll make it nullable. And it's because that seems apropos, making it an optional, and then it's just going to be, and then what I'm going to do is I'm going to return the token cost. So if these aren't equal, so now I know that it's going to be a presses or val cost equals, and it's going to be a presses times a token cost plus b presses times b token cost. And then if token cost is less than best token cost, then best token cost equals token cost, and best presses equals a presses to b presses. I don't know why I'm tracking that, but why not? Well, yeah, that means these need to be vars. And then it's just going to be, so now I'm actually doing sum of, and it's just going to be best token cost. And I return. $478, $480. How am I getting it off by one? What? How am I? It costs 3 tokens to push A, 1 token to push B. And I'm getting the right values, 80 and 40, 38 and 86. So how am I? How is my? Wait, what? What? How am I getting 478? How am I getting 280 plus 200? Let me take out this best presses for because I actually don't need that. I have no idea why this is happening. This is weird. Am I somehow decrementing best token cost at some point? Wait, what? I'm. What the hell is that? How am I? Oh! Fuck me. I'm stupid. Wow, I'm an idiot. Holy shit, I'm an idiot. Okay. I was getting a wraparound. I was taking it max, and that was included in the sum. That was very Okay. Now I can test with the proper input. How big is the input? Okay. So let's test with the proper input, which I know I went super, super slow here. But part of it was me just, I'm tired and I'm not doing math well. I'm an idiot, is what I'm trying to say. I'm absolutely fucking stupid. And that's why I'm slow. Oh, please don't wake up, Ben. This has become pretty consistent where I get like almost done with day one and he just can I wait, like this is how tired I am is I forgot to even just submit the thing. Part two is gonna suck. Yep, now they're longs. So actually though, I think my approach, don't wake up. Please don't wake up. Please, please, please don't wake up. It has been every single night, 5 times a night, Ben. Please don't wake up. Okay. Here's what I'm going to do. Machines dot. The nice thing is, I think if I just take out this 100, I'm actually okay. But let me leave it there for now. So it's going to be machines dot map, and it's going to be machine dot copy, and AX and BX are the same, but it is. Let me just change all of these to longs. Change all those to longs. Please don't wake up, Ben. Please, please go back to sleep. He hasn't like started screaming yet, but it's just a matter of time. I'm worried. Okay. So first, let me just do return 0. By the way, Control W highlights the token. If you didn't know in IntelliJ, it's Control W and Control V. I'm making sure that I haven't broken part 1. Okay. I have not broken part 1, which is good because actually now part 2 is easy, I think. Like what I'm doing here is going to probably work pretty well for part 2. I'm not going to say it's going to be the fast. Well, hang on. Actually, no. I could end up with a serious problem. We'll find out. Machines.copy, but it's going to be const val part2 target change equals actually no. Come to think of it, what I'm going to have to do on part 2, I think, is figure out basically how to move a square from this. So I think I just need to do the LCD of these four numbers. Or the LCD of this with this, and the LCD of this with this, and then the LCD of those two. We'll try that second. Yeah. Come to think of it, these numbers are too big for my approach to work. So we'll do machine, or it's going to be target X. Yep. Val big machines. Any Google Dolls fans in the house? Then return part 1. Hmm. Let's just see if this works. Oh, well, would help if I'm not returning 0 immediately. What? Sorry, I'm extraordinarily tired, which is why I'm not talking aloud right now. How is literally nothing happening? Oh, right, because I'm still doing min 100. Yeah, that's what I thought. Okay, so what I'm gonna have to do is I need to move 8400, and then I need to figure out a square distance. And so it's going to be um because if I can get to okay, so he doesn't actually give you a sample solution for this, which leads me to believe that there's a trick. I think what I want is okay, so let's try this real quick. Let's do how big is AMAC? Okay. That's how big AMAX is. But to be clear, it's a big number. But I only actually need to check one out of every 94 of those. Because it's going to be line um machine.ax mod AMAX. No, not mod AMAX. It's going to be wait. Did that just say 94? Are all of these evenly divisible? Because I'm going to be extremely mad if they are. No, print line. Oh, I'm doing it backwards. That's why. I was going to say like okay, machine.ax. So we're going to get the mod 14. Now, what I know is that I need to find a combination of X that mod. Yeah, I'm too tired for this right now. I can do the math. I can't do it right now. I'm gonna try this tomorrow when I have some time. I might do it in the evening. I'm just I can feel myself doing the math and almost getting there and then stopping. Because my first thought was, okay, let's just do a square to get to this point twice. But the problem is I have no guarantee that I need to get there and then use my existing solution. Um, and so now what I'm trying to do is do the mod, but I need to graph this out, and I'm just my brain is slipping away. So for the first time this season of Advent Code, I am not doing part two right away. Um, I technically gave up because the 11th, but then I came right back. Like I didn't go to bed. I'm going to bed this time. I'm too tired, and the math that I need to consider here is getting away from me. I know I need to take into account like the mods, maybe the GCDs. Um, yeah, I'll figure it out. Have a good night.